In this video, we're going to write the equation of a line in standard form. So far, we can write the equation of a line in two different forms. The first form that we started with is point-slope form. And remember, this is where we always start when we're writing the equation of a line. And this is the equation where we have y minus our y-coordinate is equal to m times in parentheses x minus our x-coordinate. So we need a point and a slope to write this equation of a line, and we always start here. Then from here, we know how to rewrite point-slope form into slope-intercept form. And we always start in point-slope, and then we rewrite it into slope-intercept form. And that's where we have y equals mx plus b, where our y value is alone. So what we're going to do today is we're going to learn about a third form of an equation of a line and talk about how we would write our equation of a line into that third form. So our third form of a line is called standard form. And a couple of key characteristics of standard form. I want you to first note that all of the variables, so we have our x's and our y's, our variables are together on one side of the equation. So you can see that on the left-hand side we have the coefficient of x times x plus the coefficient of y times y. So the variables are together on one side of the equation. On the other side of the equation, that constant value, so the number that has no variables, is all by itself. So in standard form, this is where we ultimately want to end up. We want to end up with the constant on one side of the equation by itself, and then we want all of the variables on the other side of the equation together. So in order to write the equation of a line into standard form, we're essentially going to take what we already know about writing the equation of lines and simply add one step to it. So what we're going to start with is we're still going to start in point-slope form. So what that means is we're going to need to find our slope and find a point if needed. So that's where we're going to start here. Then we're going to rewrite the equation into slope-intercept form. And then once we've done that, we're going to take one more step and we're finally going to rewrite it into standard form, which is when we get our constant alone. So notice how similar the steps are from writing the equation for a slope-intercept form equation or a point-slope form equation. So here to start, we're going to find our slope if it's needed, which we can see we have 2 points. So I have x1, y1, x2, y2, so I can see that, yes, in fact, I do need to locate my slope. So here I have m equals, I have y2 minus y1 over x2 minus x1. So a lot of negatives going on here. So from here I'm going to utilize keep, change, change, keep, change, change. Negative 6 plus 9 is 3. Negative 1 plus 2 is 1. So I have a slope of 3 over 1, or 3. Then from here, I'm going to start by writing the equation of my line into point-slope form. So we always start here in point-slope form once we have a point and a slope. We need to pick a point to use. I'm going to pick this first point here. Remember, it does not matter which point you pick. So I'm going to start by writing it into point-slope form. So I have y minus my y-coordinate, which is negative 9, is equal to my slope, which is 3, times x minus my x-coordinate, which is negative 2. Here I'm going to utilize keep, change, change, keep, change, change. So my point-slope form is y plus 9 is equal to 3 times x in parentheses plus 2. So here I have my point-slope form. Then what I'm going to do from here is I'm going to rewrite that equation into slope-intercept form. So I know that to start doing this, I need to distribute to get rid of those parentheses. So here I'm going to get y plus 9 is equal to 3x plus 6. And then in order to get it into slope-intercept form, I need y alone. So I'm going to subtract 9. So I have y is equal to 3x plus a negative 3. Then finally, to end, I want to end in standard form, which means my constant value with no variable is what I want by itself, which in this case is this negative 3. So there's no variable attached to it. I want to get it by itself. So essentially what we need to do is we need to undo this 3x here. And if we want to undo an entire term, we need to subtract it. So notice how these added together will become 0 from each side. Now remember, in standard form it goes ax plus by is equal to c. So we want our x's first, which in this case I can see I have a negative 3x plus my y's are second, which is just y, is equal to my constant term by itself, which is negative 3. So essentially we start just where we started before in step 1, finding the slope, work through point slope form, through slope intercept form, and then ultimately end in standard form. So here again, we're going to write the equation of a line into all three forms, utilizing the 2 points that we see on the screen. So in order to start this whole process, we need to find our slope. So that's exactly where we're going to start. So we're going to label our points x1, y1, x2, y2. So we have 4 minus a negative 4 over 3 minus a negative 3. So I utilize keep, change, change, keep, change, change, and I end up with 8 over 6, which because they're both divisible by 2, that simplifies to be 4/3. So that is the slope of our line. Then what we're going to do from here is we're going to always start by writing our equation into point slope form. So I'm going to start with a point and a slope. I'm going to pick this point right here because everything is positive and I like the positive values. It makes my life easier. But remember, you can pick either point, it doesn't matter. So we're going to start here in point slope form, which I'll do in purple. So we have y minus our y coordinate of 4 is equal to our slope of 4/3 times x minus our x coordinate of 3. So then from here, remember, this is your point slope form. You took a point, you took a slope, and you substituted in. Now my next step is I'm going to rewrite this equation into slope-intercept form. And in order to do that, I need to start by rewriting this equation with no parentheses, and so y is alone. So I start by distributing. I'm going to use keep, change, change here as I distribute. So here I have y minus 4 is equal to 4/3 x plus, this one's a little tricky, so we're going to do 4/3 times negative 3 over 1, which becomes a negative 12 over 3, which is negative 4. So as we distribute that 4/3 and multiply it by negative 3, we get negative 4. Then what we need to do here is note that y is not quite alone, so we need to keep working by adding 4 to each side. And as we do that, we end up with y is equal to 4/3 x, and this is a plus 0, or you can just write y equals 4/3 x. But here, when we get y alone, this is when we are in slope-intercept form. So that's when we have y by itself and everything else on the right-hand side of the equation. Then finally, my last step here is I want to write my equation into standard form. So I'm going to get the constant alone with no variable, which is this 0 here. So I'm going to subtract 4/3 x from each side. In doing so, these will cancel out. So we'll end up with negative 4 over 3x plus y, so notice I put the x's first, the y second, is equal to 0. And once I get that constant value alone, that is my standard form equation. So same process here, just a slightly different look. We're going to write the equation of a line that goes through those points listed below into point slope, slope intercept, and standard form. So we're going to start by finding the slope, which we can do with that y2 minus y1 over x2 minus x1 equation. But because we have a graph here, we can actually utilize the rise over run, which is what I'm going to do. So here, to move from the point in red to the point in black, I need to vertically move in the negative direction 2. So I have negative 2 is my rise, and my run is a positive 3 in the x direction, so I have a positive 3. So my slope for this line is a negative 2 over 3. Then from here, what we need to do is we need to write the equation of a line into the 3 forms. So we always start with point slope form. We need to pick a point, and then we have our slope. So I'm going to pick the point negative 4 comma 3. So here I have y minus my y coordinate of 3 is equal to my slope of negative 2/3 times x minus my x coordinate of negative 4. So I utilize keep, change there, and my final point slope form equation is y minus 3 is equal to negative 2/3 x plus 4 in parentheses. So this right here is our point slope form. Then we're going to move on and we're going to find our slope intercept form, which remember is when we have no parentheses and y is alone. So here I distribute the negative 2/3. So we have y minus 3 is equal to negative 2/3 x. And then we need to figure out what negative 2/3 times 4 is. So I do negative 2 over 3 times 4 over 1, which ends up being negative 8 over 3. So here we would do plus negative 8 over 3. Then from here I need to get y by itself to be in slope intercept form. So I add 3 to each side. So I have y equals negative 2/3 x. And then I have negative 8/3 plus 3. So that could be 3 over 1. We need a common denominator. So that's really, if we multiply everything by 3, that's really 9 over 3. So that's negative 8/3 plus 9/3. So here we really have negative 2/3 x plus 1/3. So that is my slope intercept form. And then finally from here we want to end in standard form, which is when we have the constant, which here is 1/3, by itself. So we need to move that x term completely. So we're going to add 2/3 x, add 2/3 x. And so we ultimately end up with 2/3 x plus y is equal to 1/3 for our standard form. Remember here, our constant value is alone, and our x's and our y's are together on the other side of the equation. In this example, we're going to write the equation of a line in point slope, slope intercept, and standard form for items that are written in function notation. So here, remember, we need to start by translating what this function notation is really telling us. This is really saying when x is equal to 1, y is equal to 2. So this is really the point 1 comma 2. And here in the second one, it's saying when x is 3, y is negative 4. So we really have the point x is 3, y is negative 4. Then I know that I always need to start in point slope form. So now that I have some points, I need to find my slope of my line. So here we're going to have x1, y1, x2, y2. So we have negative 4, which is y2, minus y1, which is 2, over x2, which is 3, minus x1, which is 1. So we end up with negative 6 over 2, or a slope of -3. So then from here, we're going to move forward now that we have a point and a slope, and we're going to write our equation into point-slope form. So we need to pick a point, and I'm going to pick 1, 2, and then we need our slope. So we go to our equation, and we write y minus our y coordinate of 2 is equal to our slope times x minus our x coordinate of 1. So this is our point slope form. Then from here, we're going to rewrite it into slope-intercept form, which is when y is by itself. So the first thing I need to do is distribute the -3. I'm going to use keep change to prevent an error. So I have y minus 2 is equal to -3x, and then -3 times a -1 is a +3. Then in order to be in slope-intercept form, I need y to be alone, so I add 2 to each side. So we have y equals -3x plus 5. And that right there is my slope-intercept form, because y is by itself, and I can identify my slope and my y-intercept of that line just from looking at the equation. And then finally, we're going to rewrite this into standard form, which is when this y value here is completely alone. The constant value is by itself. So in order to get that into slope-intercept form, I need to move the 3x term entirely by adding it to each side. So it becomes 0 over here. And our standard form becomes 3x plus y is equal to 5. So notice here that our constant value of 5 is by itself, and the x's and y's are grouped together on the other side of the equation, with the x's coming first and the y's coming second. So standard form is actually really helpful for when we're dealing with a very specific type of word problem. And you're going to see that here in this example. So these are typically called cost word problems or cost equations. And you'll see why as we read through this together. So this example says you are at the grocery store and need to purchase fruit for your team breakfast. Apples cost $5 per bag, and mandarin oranges cost $6 per bag. Your mom gave you $90 to spend on fruit, and you intend to spend exactly $90. So here we need to write an equation in standard form to represent the situation. Here we can see that we're calculating cost. Our cost, which I'm going to write out, is calculated by taking the number of bags of apples times the price of apples, added together with the number of bags of the oranges times the price per bag of oranges. So that's really how we calculate our cost in this situation. Now, let's fill in some of those pieces that we know. The first thing we know is we know that our cost is going to be exactly $90. So we can substitute the 90 in for our cost. We then don't know how many bags of apples we buy. So here I'm going to represent bags of apples with X because it's an unknown, times our price, which is $5 a bag, plus the number of bags of oranges, which in this case I'm just going to call it Y, it's another unknown value, times the price of oranges per bag, which is 6. So you can see here you take your cost, and it's calculated by number of bags of apples times the price of apples, plus number of bags of oranges times the price of oranges. Now typically when students write this, they will write the variable second. So our equation would be 90 is equal to 5x plus 6y, with x equaling the number of bags of apples and y equaling the number of bags of oranges. So now we're going to utilize this equation in order to make predictions. So here we can see that our equation is 90 equals 5x plus 6y. And here we can see that we purchased 6 bags of apples. And remember, X is our number of apples. So what we're going to do is in X, we're going to replace X with 6 because we know that we bought exactly 6 bags of apples. And we're trying to figure out how many bags of oranges we can buy if we bought 6 bags of apples. So here we have 90 is equal to 5 times the 6 plus 6y. Well, I know that 5 times 6 is equal to 30. So then I subtract 30, so I have 60 is equal to 6y. Divide both sides by 6. And I find that I have y is equal to 10 bags of, remember y is oranges. So essentially what I discovered is that if I buy 6 bags of apples, I can buy 10 bags of oranges. Now if I flip this around in part C, I'm starting with that same equation of 90 is equal to 5x plus 6y. But here in this problem, they're telling me something different. They're telling me we're purchasing 5 bags of oranges. Remember, oranges is our y variable, so we're going to substitute that value in for y and find how many bags of apples we can pair with that. So here we have 90 is equal to 5x plus 6 times 5. So 90 is equal to 5x plus 30. Subtract 30, subtract 30. Here we have 60 is equal to 5x. Divide by 5. And I find that when I buy 5 bags of oranges, I can actually buy 12 bags of apples. So standard form is great for these cost calculating equations where we have the cost is equal to, and then you have the number of that item times its price plus the number of another item times the other item's price.